Okay, so this is one of the more well-known problems. I think everyone gets asked to calculate the number of primes with between two values at some point, or the number of primes within a 2D array, for example. But you often see this count the primes as the title for a problem. So in this case, we're going to be using recursion to count the number of primes between two values. User input values where start is less than the end. The second part of the problem is something I'm going to ignore for the time being. It's a little bit more complex. I'm going to just go with the simple and smaller versions. Again, there won't be any loops used, just recursion. To save a little time, I've done the user prompts we'll need a little bit of space there. So we're going to be calling the function count primes using our start and end. So what is our base case going to be? Well, what we really want to do is look at each number individually, decide if it's a prime or not, and then add 1 to our count if the number is found to be a prime. So to do this, we're going to be incrementing our start value each time. Let's say we've used 10 and 20 from the example. We'll basically be incrementing start each time until the start value increments to 21, not 20. And at that point, that's when we're going to return a value of 0, because we don't want to be adding anything extra or anything outside of our boundaries to a count. So let's say we want to end at 18. Well, if we return a 1 here, it's wrong. Anyway, needless explanation aside, the second part of this count primes function, we know that we're going to need to return, well, it could be 0, but ideally we want to make sure we return the number of primes. So we call this bool function isPrime using start, and if it returns as true, we're going to add 1 to our rolling return total and call the function count primes, but incrementing our start each time. If isPrime returns false, then we're just going to count primes, incrementing start. So, so far, self-explanatory, but we need to sort out this bool function. The signature is isPrime, uses int value and an int check. Basically, we're going to be doing a couple of rudimentary steps to make sure that our value is prime. If our value is 2, return true. That's very easy. We know 2 is well, most people would realize 2 is the first prime number. But we need to set the rest of the conditions. If our value is less than or equal to 1, or if our value modulo 2 leaves a remainder of 0, that is, if value divided by 2 leaves a remainder of 0, then we're going to return false. We know that we're going to need to increment the check at some point. Basically, what we do with isPrime is we take the value start, it could be 10, 11, 12, whatever, and then we're going to divide it by our check value, and if our value modulo check equals 0, that is, let's say we have a value and it divides evenly by anything, by our check value 3, 4, 5, 6, 7, all the way up to the value itself, then it's not a prime number, so we return false. But when we are calling this function recursively, one of the things we'll be doing is incrementing check each time, keeping value the same. However, there will be a point where check reaches value itself. So before that happens, and before we have value divided by check equaling 1 and leaving a remainder of 0, this condition is vital. If value equals check, then we have a prime number. We're returning true. So that's so far. I think this is accurate and hopefully it's correct. It's not the most efficient solution, but it does work. Let's look at the values. We'll use 10 and 20, and the number of primes is 4. That is 11, 13, 17 and 19. We'll do one more check. 10 and 200. 10 and 200, and the value is, the number of primes is 42. I'll let you Google what they are. Thank you.